So you're building an application. Awesome. But pretty quickly you're going to hit a major fork in the road, a decision that can literally shape your entire project, SQL or NoSQL. It's one of the biggest debates in tech, so let's break it down and figure it all out.
Okay, let's just dive right in. Because honestly, right out of the gate, most people start this conversation from a place that completely misses the point. They frame it like some kind of cage match. You've seen it everywhere, right? The blog posts, the YouTube comments, SQL versus NoSQL. Which one is better? It's always set up like this big showdown where there has to be one winner and one loser.
But that is totally 100% the wrong way to think about it. It's not just a simple question. It's a fundamentally misleading one.
And as this developer on YouTube so elegantly put it, focusing on the query language, the SQL part of the name, is kinda silly. The real difference, the thing that actually matters, isn't about the language you use to ask for the data. It's all about the philosophy of how you store it.
So this is the real starting point: relational versus non-relational. A relational database is all about the connections, the intricate web between different pieces of data. While a non-relational database is more like a filing cabinet, it's focused on individual documents, each one holding its own information. Understanding this one shift in perspective is the key to everything else we're about to cover.
All right, so let's dig into that first big difference, structure. This really gets to the heart of how these two types of databases think about organizing your information.
So a relational database, our SQL database, is like a super organized spreadsheet, actually a whole collection of them. Before you can put a single piece of data in, you have to create a strict blueprint, a schema that defines every table, every column, and what kind of data goes where. Everything has a very specific box it needs to fit into. Let's make this real. Imagine you're mapping out a city's train system. In a relational world, you'd have one table just for the train lines, another one just for the stations, and then a third table whose only job is to connect them. It uses special keys, these IDs, to create a link saying, hey, the red line stops at this station and that station. The data is kept separate but is all tied together by these relationships. Now on the flip side, a non-relational database, or NoSQL, basically takes that rulebook and throws it out the window. It's built on a dynamic, flexible schema. You don't have to define everything up front. You can just start throwing in your data as documents or key value pairs or whatever makes sense. And this is a perfect example of that freedom. See how this one single record for a MacBook Air contains everything about it? All its specs, storage, CPU are nested right inside. And the next record could be for a t-shirt with totally different fields like size and color. The database just doesn't care. It handles both perfectly. That's the whole magic of a dynamic schema.
Okay, so your app's a huge hit. Congrats! But now you have a new problem. A good problem, but a problem nonetheless. Your data is growing like crazy. So how do these different database types handle all that load?
This right here is one of the best analogies for understanding the difference. SQL databases usually scale up. It's called vertical scaling. When you need more power, you get a bigger, beefier server. More RAM, faster CPUs. It's like adding more floors to a single skyscraper. But NoSQL databases were born to scale out, or horizontally. You just add more, cheaper servers to the group. It's like building a whole sprawling city instead of just one tall building. One has a limit, the other not so much. All right, so we've got structure and we've got growth. Now for the really serious part, trust. How do these databases make sure your data is accurate and reliable, especially when things go wrong?
SQL databases live and die by a principle called ACID compliance. Now, you don't have to memorize the acronym, but you do need to know what it promises, that every transaction is basically perfect. Think about a bank transfer. The money has to leave your account and arrive in your friend's account. It's all or nothing. If anything goes wrong, the whole transaction is rolled back like it never happened. For things like finance, this is absolutely non-negotiable.
NoSQL databases play a different game, and it's best explained by something called the CAP theorem. The short version is that in a distributed system, you can only pick two of these three things: perfect consistency, constant availability, and partition tolerance. NoSQL often decides to sacrifice immediate perfect consistency in favor of always being online and available. This means for a split second, some data might be slightly out of sync across the system, but it will catch up. We call this eventual consistency. Okay, so that was a lot of theory. We've got these major trade-offs in structure, scale, and consistency. So what does this all mean for you? When do you actually pick one over the other? Well, it all comes down to using the right tool for the right job.
You're going to want to reach for SQL when your world is predictable, and correctness is everything. If you're building a banking app, an e-commerce backend, or anything where the relationships between your data are complex and you absolutely cannot afford for a single transaction to fail, well, SQL is your battle-tested, reliable friend.
But if you're dealing with massive amounts of data that doesn't fit neatly into tables, think social media feeds, IoT sensor data, user profiles, NoSQL is going to be your hero. It's built for the wild, unpredictable scale of the modern web, where being online and fast is more important than being perfectly consistent every single millisecond.
Okay, but here's the real secret. The one thing those Versus articles never really tell you. The most sophisticated, powerful applications out there, they don't choose. They use both.
And there's no better example than an e-commerce website. Think about it. All that browsing, clicking, adding, and removing items from your cart, that's messy, temporary data. It's perfect for a super fast, flexible NoSQL database. But the second you hit that Confirm Purchase button, whoosh, that final critical order information gets sent over to a rock-solid, ACID-compliant SQL database for billing and shipping. You get the best of both worlds.
All right, let's zoom out now and bring everything we've talked about together. It's time to connect all these dots into one complete picture.
So here's how it all fits together. We started by changing the question. It's not SQL versus NoSQL, it's relational versus non-relational. And you can see how that single decision creates a cascade. If you go relational, you're choosing rigid tables, which leads you to scale vertically and demands that strict ACID consistency. If you go non-relational, you get flexible documents, which lets you scale out horizontally and means you'll be working with eventual consistency. It's all a connected chain of trade-offs.
So I'll leave you with this final thought. The choice was never about which database is better. It's about what you're trying to build. So ask yourself this. For your next project, are you designing a single, perfectly engineered skyscraper where every beam has to be exactly right? Or are you building a sprawling, resilient city that can grow and adapt in any direction? Your answer to that question will tell you exactly which tool you need to pick up.